Girls, we're going to summarize everything that we learned. Okay, we've learned, as you can see, 6 different types of functions or graphs. Okay, it can be quite confusing to distinguish which one is another. All right, so we're going to start with straight line. Which one of these is straight line?
1.
Number 1. How do you know it's number 1?
Because there's no square.
Yeah, that's right. Girls, if it's just x without any power, in this case the power is technically 1, it's a straight line. Okay? Let's just keep going. Which one is parabola here?
2.
Yeah, it's number 2 because the power is 2. Okay? It's a cubic curve for 6 because?
It's got a 3.
Yeah, because the power is 3. Exponential?
5.
Yeah, exponential is number 5 because the power itself is x. Hyperbola?
3.
Hyperbola is number 3 when you have x as a denominator. And lastly, circle, we just learned yesterday, is number 4 when you've got x squared and y squared. Okay, so we're going to summarize all of these graphs and let's see how to draw them using transformations. Okay, basic stuff, straight line, we learned this the topic before. You need to find 2 things, the y-intercept. So from here, the y-intercept is clearly -4, the number without x. I'll just get rid of this. The x-intercept, girls, what do you make it equal to?
0.
Y equals to 0, so we're going to solve 0 equals to 2x minus 4. And as we can see, if I just skip the steps, yeah, x is equal to 2. So I'm going to label -4 on the y-axis, which is here. And 2 is there, and then, yep, join it up. Okay? Now, with parabola, girls, we know, let me do it in black. We know y equals to x squared is just a normal parabola like that. But we've also learned if you have a number in front of the x squared, it gets narrower. So a narrow graph like that. But in here, we've also got y equals to 2x squared minus 3. What does the minus 3 do to the graph? Shifts the graphs down by 3 units down. So I'm going to put minus 3 here. And you're going to have the same graph, but just shift it downwards here. Okay? Remember, furthermore, if you wanted to find the x-intercept, you'll need to solve for x. What do you need to make it equal to? Yeah, make it y equals to 0 and solve for x here if you further want to find the x-intercept, which I'm not going to go through here. Okay? Girls, cubic curve. We know the basic cubic curve is y equals to x cubed. And do you girls remember if it looks like this? 1 or 2?
Oh, 1.
This way. Yeah, it can be confusing. That's why I asked. Okay?
I didn't say 1.
Now, if there is a minus in front, that's when you draw it the other way around. Okay, so this way. Now, from here, if you added 8, what does it do?
Shift up.
Shift up by 8 units. So instead of being at the origin, I'm going to draw the same graph at 8 and just draw that the center of the cubic curve. Okay? So it's all about using transformations. Now with exponential, we've learned that we started off with y equals to 2 to the power of x, and it basically looks like a graph like this, where it will always go through what?
1.
1, because anything to the power of 0 is 1. And we've learned from here, when the number increases, so let's say 5 to the power of x, it's the same graph, but it gets narrower. Yep. But now, here, in this case, because we've now got y equals to 5 to the power of minus x, it's the same graph but reflected what? Horizontally or vertically? Horizontally, to the sidewards. Okay? So same graph but reflected sidewards. Okay? So this is how we drew that graph. Yeah? And then we also wanted to put a point, but for now we just look at how everything looks like in general without too much detail. Okay, hyperbola. What was our basic equation for hyperbola? Y equals to what over x? Do you remember? 1. Okay, and that looked like this. Yeah, remember that?
Oh, yeah.
Okay. Now, if the number on top increases, so let's say in this case we've got 4 over x, do you guys remember what happens to the curve?
It moves away.
It moves further away from the origin. That's right, so I could just basically draw a curve like this.
You have to draw 2.
Sorry?
Now,
Now, in our case, we've got y equals to -4 over x. So how does it change from the purple graph? It's just the other side, like this. Okay? Yeah, remember that? Okay, lastly, circle. We learned from yesterday, it's a circle if it's in this form. And from here, what's the radius? Yeah, radius is square root of 9, which is 3, where the center is at the origin. Yep, so draw a circle around it with 3 units all around the circle. Okay, and that's...
So do you have to like write the 3?
Now, further graphs, same thing, but we've learned how to transform the graph if it's in a bracket. Firstly, what type of graph is this out of all the ones that we just drew?
Parabola.
It's a parabola because of the power of 2. Yep. Now, if it's in a bracket, we learned that it shifts
Right.
either to the left or right, depending on the value inside. And in this case, x is equal to plus 2, taking the opposite sign. So that means it's a graph shifted 2 units to the right. So the vertex will be there. And then you just have to draw a graph. Okay. What effect does a 2 do to the graph? Make it narrow. Okay. And then we also learned to figure this out, which is the Y-intercept, by substituting x equals to 0. In this case, if I do that, just quickly, then y will be equal to 2 times 0 minus 2 squared. You know what that would be? 2 times 4?
8.
Yeah. Okay? Yeah, so we learned that. So if it's in a bracket, it shifts to the left or right. Okay? However, if it's like that, how should we start drawing that graph, 1 minus x squared, using transformation? What should I draw first? Draw this first, minus x squared. If they ask you to draw this graph using transformation, this is your graph of minus x squared. Yeah? And then if you got plus 1 on top, that means you're shifting this graph 1 unit up. So now you would draw the same graph, but just shift it up. Okay? And furthermore, if I wanted to find out those x-intercepts, do you girls remember what to do if you want to find the x-intercept of a parabola? Factorize it. That's right. Remember to factorize it to find.
Do you have to?
No, actually, no, you don't. Yeah, you can actually solve it. Yeah, that's right. Or if you just make y equal to 0, 0 is equal to 1 minus x squared. Yeah, that's right. Then that means x squared is equal to 1. So what does x equal to, girls? Plus minus 1. Why is it plus minus 1?
So this is square.
Yeah, when you square root 1, it's plus minus square root of 1, which is plus minus 1. Yeah? All right. Girls, this one. What kind of graph is that? No, very hyperbola. How do we know it's a hyperbola? Because if you've got a fraction with x as a denominator, it's a hyperbola. When we had something like this, we made that equal to what?
0.
0. What was the reason for that?
Because you can't
have
a base.
you can't have 0 as a denominator. So what does x equal to here?
4.
4. That is your what's the other word? Asymptote. Yeah? Remember, this is your asymptote. Because you can't have 0 as a denominator, the x value of 4 is a part that the graph will never touch. So x equals to 4 here, and then we drew a dotted line, remember? Now, if the question was just 2 over x minus 4, the graph will look like this. Yep. But because in our question there's a minus, we have to draw it the other way around, like this. Okay, so I will rub out the dotted line. Yeah, because of the minus, you have to draw it this way. Okay, bounded by this. And remember, the x-axis is also the asymptote itself. So you'll never touch this or that line. Okay? And just as a more further fact, what else did we do on this graph to show further details? 1 point. So in this case, if I substitute, let's say something simple. See, I don't want to use 1 because if I do 1 minus 4, I'm going to get minus 2 over 3. I don't want to use decimal. Yeah, let's choose 2. So if I choose 2, so then that means y would be equal to minus 2 over 2 minus 4. And what's that? Minus 2 over minus 2? 1. So that's nice. So let's put the coordinate 2 and 1 on the graph. It looks completely out of scale. But let's just say it's there, minus 2 and 1. Oh, sorry, not minus 2, 2 and 1, sorry. Okay, so yeah, we plot a point on the actual graph to show a coordinate. Okay, last one. Girls, this is still a hyperbola because we've got x as a denominator. But in this case, what's my asymptote? Yeah, that number by itself. This was my asymptote where the line of the asymptote was y equals to minus 1. Here we had x equals to 4 as an asymptote. Here we got y equals to minus 1 as an asymptote. And that's this way. Minus 1 is here. That is the dotted line. Okay, instead of vertical, it's horizontal. and then draw that. Okay? Minus becomes this side of the graph. 8 makes it further away from the origin. So let's try and draw that like that. Like this. Okay? This is like your origin of the graph, which is further away from. Okay? As we can see, we learnt a lot, lots and lots of transformations and facts. So this is going to be a summary of everything that we've learned. Okay? Obviously not everything in detail, but this is like what you need to know and be able to distinguish from one graph to another. Yeah.
So you know for that equation, what about if you add like plus 1 to the end of that fraction?
But plus 1 to that, or then it'll be this graph, shift it up. So that means you have to draw asymptote of y equals to 1. So it will be like this.
Because right now the other asymptote is...
I'll rub this out, and then I'll draw this.
And the other asymptote changes as well.
Yeah, does that make sense?
Origin, if that graph up there had a plus 1...
Yeah, cool. Any questions? All right, cool. Thanks, Kios. Do the rest of the exercise.